So as I told you in the last video, in Java, we have an interface called map. This interface is declared in the java.util package, and it's part of the collections framework, but it's not part of this hierarchy that you saw earlier. So it's not a collection, it's not an iterable, it's something entirely different. Now, as you can see over here, this interface has two generic type parameters, k and v, which are short for key and value. So with a map, we're essentially mapping a key to a value. This value could be an object like a customer, and this key is something that we use to look up that object, like look up that customer. Let's say we want to look up customers by their email. So we create a map of string to customer. So our keys are going to be strings and our values are going to be customer objects. We call this map and set it to a new hash map. Again, this interface has many different implementations, but the one that you use most of the time is the hash map class. Now let me create a couple of customer objects over here. So C1, we set it to a new customer. Here we should pass a name, let's say A, and then an email, let's say E1. I'm going to duplicate this line. Let's create the second customer, call it B with E2 as the email. Now we want to store these customers in our hash map. So we type map.put. This method has two parameters, a key, which is a string, and a value, which is a customer. So here I'm going to pass C1.getEmail. I'm going to use the email of this customer as a key to look it up. And then I pass the customer object itself. Similarly, we add the second customer. Now to get a customer from this hash map, we type map.get. We pass the key, let's say E1, and this will return a customer object. So if we print this, what do you think we're going to get? We're going to see the name of this customer. So there you go. So instead of using a loop to iterate over a list, we call the get method of the hash map to get an object. And this is extremely fast. It doesn't matter how many objects we have in this hash map. We could have 1 trillion objects. The cost of finding a customer is constant, and it would be very, very small. Now, what if we look for a customer that doesn't exist in this list? Let's say E10. We get null. Here we have a similar method called get or default. So we can pass the key and a default value if this value we're looking for doesn't exist. So in this case, we can pass, let's say, an unknown customer. So I'm going to create an unknown customer over here, new customer. The name is unknown and the email is nothing. So I'm telling this map, look for an object with the key E10. And if you cannot find it, return this unknown customer. Take a look. Now we get unknown. Another useful method is contains key. So here we can call contains key. We want to see if you have a customer with this email, E10. Obviously, this returns a Boolean. So let's rename this to exists. Now we run the program. We get false. We also have a method for replacing an object in a hash table. For example, we can call replace, and we want to replace this customer with the email E1 with another customer object. Let's say we made a mistake, and this customer object, its name should be A++ with the same email. Now, this method is going to replace the customer. So if we print our entire map, you can see that this map has two key value pairs. Here's the first key value pair, and here's the second key value pair. So this is the reason this interface is called map in Java, because it maps a key to a value. In C# and Python, it's called a dictionary because it's kind of like a dictionary where we have words and their meanings. So each piece of data has two components, a key and a value. Okay. Now, as I told you before, this map interface is not an iterable object, so we cannot use it in a for each loop. So if we write for each item in map, look, we get a compilation error because this is not iterable. So how can we find the objects we have stored in a map? Well, here we have 3 methods. One of them is keySet. This returns the list of keys in this map. This object is iterable, so we can iterate over it. In each iteration, we get a key, so we can print it over here. There you go. These are our keys. We have a similar method called entry set. Now look at the return type of this method. It returns a set of entry of string and customer. So it returns a set, and because sets are iterable, we can iterate over them using a for each loop. So in each iteration, we get an entry. This entry, if we print it, we see something like this, key equals value. Now we can also get the value by calling the getValue method or the key. So if you need to access both the key and the value in each iteration, you should iterate over the entry set. And finally, we have another method called values. It returns a collection of customers. So this is also iterable. Let's rename this variable to customer. So in each iteration, we get one customer. So A and B. And by the way, the order of these customers is not guaranteed, exactly like our sets. So just because we added customer 1 before customer 2 doesn't mean when we print these customers, they're going to come out in the same order. So this is all about the map interface in Java.